Imagine two people walk into the same room at the same time. Nothing unusual about the room. It's a normal social setting, people talking in small groups, soft music playing in the background, occasional laughter rising above the noise, chairs moving, subtle shifts of attention as conversations overlap and fade. For one person, the experience feels almost immediately engaging. Their attention sharpens, not in a strained way, but in a focused, energized way. They begin to pick up patterns, who is talking to whom, what the tone of the conversation is, when to join in, when to respond. Their brain seems to sync with the environment. The noise is not really noise anymore. It becomes structured, meaningful, even stimulating for the other person. The exact same room produces a very different experience. At first, nothing seems wrong. They hear the same sounds, see the same people, notice the same movements. But gradually, something begins to build. The overlapping conversations don't separate cleanly. They blend together. The background music doesn't stay in the background. It competes for attention. Every voice, every movement, every small change in the environment seems to demand processing. There's no clear moment where it becomes overwhelming. It's more like a slow accumulation, a growing sense that too much is happening at once. This person may still be smiling, still participating, still appearing normal from the outside. But internally, the system is working harder and harder to keep everything organized, to keep everything clear. After some time, they step outside, not suddenly, not dramatically, just quietly. And here's the important part. They don't leave because something is wrong in the usual sense. They're not necessarily anxious. They're not afraid. They're not even avoiding people. They're responding to a limit that is not visible in the room itself, because the room hasn't changed. The sounds are the same. The people are the same. The environment is identical. What's different is the experience. And that difference doesn't come from the outside. It comes from how the brain is processing what's happening. This is where the common explanation, introvert versus extrovert, starts to fall short. It sounds like a personality label, like a simple preference, as if one person likes noise and the other likes quiet. But that explanation doesn't really capture what's happening, because this is not just about what someone likes. It's about how their brain responds. The same physical environment can produce completely different internal states depending on how incoming information is handled. What feels stimulating and energizing for one brain can feel dense and demanding for another. So the real question is not just why some people leave the room. The deeper question is, what is the brain doing differently in each case? What mechanism creates this invisible limit? Because whatever that mechanism is, it shapes something fundamental, not just behavior, but experience itself. To understand what's happening, it helps to move away from personality labels and look at something more basic, how the brain handles stimulation. At every moment, your brain is receiving information from the world. Light enters your eyes. Sound waves reach your ears. Subtle changes in posture, facial expressions, tone of voice, all of these are being detected and processed, often without your awareness. You can think of this as a continuous stream of input. But the brain does not treat all input equally. It has systems that regulate how much of this information is processed deeply and how much is filtered out. This regulation is not the same in every person. Imagine a control system with a kind of baseline level of activation. This baseline determines how alert, how responsive, and how stimulated the brain feels at any given moment. For some people, this baseline is relatively low. Their brain starts from a quieter state. In order to feel engaged or alert, they need more input, more sound, more interaction, more external activity. Without that input, they may feel bored or understimulated. For others, the baseline is already higher. Their brain is more active even in relatively calm environments. It doesn't take much additional input to push the system into a highly stimulated state. Now place both types of brains into the same environment, a busy room full of conversations and movement. The person with the lower baseline receives the input and moves toward an optimal level of stimulation. The environment brings their brain into balance. It feels energizing because it fills a kind of gap. The person with the higher baseline receives the same input, but the effect is different. Instead of moving toward balance, they are pushed beyond it. The system becomes saturated, not in a dramatic or chaotic way, but in a steady accumulation of demand. This difference is not about preference in the usual sense. It is about how close the brain is to its processing limit. And this limit is not fixed in a simple way. It depends on multiple systems working together: attention, sensory processing, memory, and regulation of neural activity. But the key idea is simple. Different brains respond differently to the same level of stimulation. This also explains why the feeling of too much can be hard to describe. There is no single overwhelming sound or event. Instead, it is the combined effect of many small inputs, each requiring processing, each adding a little more load to the system. Over time, that load accumulates. The brain doesn't suddenly fail. It gradually loses efficiency. Signals become harder to separate. Focus becomes more difficult to maintain. The effort required to stay engaged increases. From the outside, this is almost invisible, but internally it is very real. And this is why silence becomes important, not as an abstract idea, but as a functional state. When input is reduced, the system has a chance to return to a more balanced level. The constant stream slows down. The brain no longer has to manage as many signals at once. Silence in this sense is not just quiet. It is a reduction in processing demand. And for a brain that is already operating near its limit, that reduction is not optional. It is necessary. To make this difference clearer, it helps to think in terms of sensitivity rather than personality. Instead of asking whether someone likes noise or prefers quiet, imagine asking how strongly their brain responds to the same input. A useful analogy is a microphone. Some microphones are designed to pick up only strong signals. They ignore faint sounds and focus only on what is loud and clear. Others are highly sensitive. They capture everything: whispers, background noise, subtle echoes, even sounds that were never meant to be noticed. Now place both microphones in the same room. The low sensitivity microphone records a clean signal. It filters out the background and focuses on the main voice. The environment feels manageable, even simple. The high sensitivity microphone produces a very different result. It captures every layer of sound. Conversations overlap. Background noise becomes prominent. Subtle movements and distant sounds all enter the recording at once. The room hasn't changed, but the output has. Something similar may be happening in the brain. For some individuals, sensory and cognitive systems operate in a way that is closer to that high sensitivity setting. It's not that they are hearing more in a physical sense. The ears are working the same way, but the brain is responding more strongly to what is received. Each sound carries more weight. Each visual detail requires more attention. Each social cue demands more processing. This creates a richer experience, but also a heavier one. Because processing is not free. Every piece of information requires neural activity. Signals must be transmitted, patterns recognized, meanings interpreted. When many signals arrive at once, the brain must divide its resources across them. If the system is highly responsive, that division becomes more demanding. This is why a busy environment can feel different depending on the brain experiencing it. For one person, it is structured and engaging. For another, it becomes dense, full of overlapping signals that are harder to separate and organize. And this leads to a very specific kind of fatigue, not physical exhaustion, and not necessarily emotional stress. It is cognitive load. The feeling that the system is processing too much at once. What's important here is that this load builds gradually. There is no single moment when the brain decides that it has had enough. Instead, it is more like a container slowly filling. Each new signal adds a little more. At first, there is plenty of capacity, then less, then even less. Eventually, the system approaches a limit. At that point, something has to change. You can try to ignore the input, but ignoring itself requires effort. You can try to focus on one thing, but that means suppressing everything else. All of these strategies consume additional resources. Or you can reduce the input, which is what stepping into silence does. In that quieter state, the sensitive system is no longer being pushed by constant signals. The background drops away. The number of things that need to be processed decreases. And with that, the load begins to fall. From the outside, this can look like withdrawal. But from the inside, it is regulation. a way for the brain to return to a level where it can function clearly again. Silence in this context is not emptiness, it is balance restored. Once you begin to think about this in terms of processing and sensitivity, another layer becomes visible energy. The brain is not just an abstract system that handles information, it is a physical organ, and like any physical system, it consumes energy when it operates. Every signal that is processed, every pattern that is recognized, every decision that is made requires neural activity. Neurons fire, chemical signals are released, networks coordinate and synchronize. All of this has a cost. Most of the time, you don't notice this cost because the brain manages it efficiently. It filters out unnecessary input, prioritizes what matters, and keeps everything within a manageable range. But when the amount of input increases, or when the brain processes that input more deeply, the energy demand rises. Now consider what happens in a stimulating environment. Multiple conversations, shifting attention, interpreting tone, reading facial expressions, tracking social dynamics. These are not simple tasks. Each one requires coordination between different parts of the brain. Language systems, emotional processing, attention networks, memory systems, all are active at once. For a brain that processes input intensely, this becomes expensive. Not in terms of effort that you can easily see from the outside, but in terms of internal resource use. The system is working harder, using more energy to keep everything organized and coherent. Over time, that increased demand leads to fatigue. But this fatigue is not the same as physical tiredness. It doesn't come from muscles being used or from lack of sleep. It is a kind of cognitive exhaustion, a reduction in the brain's ability to efficiently process information. You might notice it as difficulty concentrating, slower thinking, or a growing sense that everything requires more effort than it should. The signals are still coming in, but the system handling them is no longer operating at full efficiency. And importantly, this fatigue can appear even if nothing stressful has happened in the emotional sense. A perfectly normal social situation can produce it simply because of the amount and intensity of processing involved. This is why the need for silence is not just about comfort. It is about recovery. When the input is reduced, when the environment becomes quiet, the brain no longer has to process as many signals at once. The demand drops. The constant coordination between systems relaxes. In that quieter state, something important happens. The brain shifts from managing external input to regulating itself internally. It can consolidate information, restore balance in neural activity, and return to a more efficient mode of operation. You can think of it like lowering the load on a system that has been running at high capacity. When the load decreases, the system stabilizes, it cools down, so to speak. It becomes capable of functioning clearly again. For someone whose brain reaches that high capacity state more quickly, this reduction is essential. Without it, the system remains in a state of continuous demand, and continuous demand leads to diminishing performance. From the outside, this may look like someone needing space or preferring to be alone, but internally it is not about avoidance. It is about maintaining the conditions required for the brain to function properly. Silence, in this sense, is not an absence. It is a necessary state that allows the system to reset, rebalance, and continue operating without overload. When people talk about silence, they often imagine it as something empty, a lack of sound, a lack of activity, almost like nothing is happening. But from the perspective of the brain, silence is not empty at all. It is simply a different kind of activity. To understand this, it helps to separate two things that are usually mixed together: external input and internal processing. In a noisy environment, the brain is constantly responding to external signals. Sounds, movements, conversations, facial expressions, all of these require attention. Even when you are not consciously focusing on them, your brain is still tracking, filtering, and interpreting them in the background. This creates a kind of continuous demand. Every new signal adds a small task: identify, interpret, decide whether it matters, and either respond or ignore. Most of the time, this happens automatically, but it still consumes resources. Now remove that input. In silence, those external demands drop away. There are fewer signals to track, fewer patterns to decode, fewer decisions to make about what to pay attention to. The brain is no longer being pulled outward in multiple directions. But it does not shut down. Instead, it shifts. Without the constant pressure of incoming stimuli, the brain begins to operate more internally. Thoughts become clearer, more extended. Ideas can be followed without interruption. Connections between concepts can form more easily because they are not being disrupted by new input. This is why silence can feel different depending on how your brain is working. For someone whose brain is used to high levels of external stimulation, silence may feel uncomfortable at first. The absence of input creates a kind of gap, and the brain may try to fill it by seeking new stimuli. But for someone whose brain is often operating near its processing limit, silence feels like relief. It is not a void, it is a release from constant demand. And in that release, something else becomes possible. Deeper processing. When external input is reduced, the brain can allocate more of its resources to internal activity. It can reflect, analyze, simulate possibilities, and organize information that was previously coming in too quickly to fully process. This is not necessarily something you notice consciously as working harder. In fact, it often feels like the opposite. It feels calm, steady, even effortless. But underneath that calm, the brain may be doing some of its most complex work. There is also another subtle effect. In silence, the brain becomes more sensitive to its own activity. Without strong external signals competing for attention, internal thoughts, memories, and associations become more noticeable. This can create a sense that silence is full, even though nothing external is happening. What appears from the outside as inactivity may actually be a highly active internal state. This is where a common misunderstanding arises. We tend to measure engagement by visible behavior, talking, reacting, interacting. When those behaviors are absent, we assume that less is happening. But that assumption is based on what we can see, not on what is actually occurring in the brain. Silence can look like absence. But for some minds, it is presence, a state where the system is no longer overloaded, where processing becomes more efficient, and where internal activity can unfold without interruption. And for a brain that processes the world intensely, that state is not just useful. It is necessary. There is another important layer to this difference, and it has to do with how information is processed once it enters the brain. Not all brains process information at the same depth or in the same way. Some systems are optimized for speed. They take in signals, extract what is immediately useful, and produce a response quickly. This is efficient, especially in fast-moving environments where quick reactions matter. Other systems operate differently. Instead of stopping at the first useful interpretation, they continue. They explore additional possibilities, check for consistency, connect the new information to existing knowledge, and simulate potential outcomes before responding. This is what we can call deeper processing. It does not mean better or worse. It simply means that more steps are involved before a response is produced. To see the difference, imagine someone asking a simple question in a group. One person answers almost immediately. The response is clear, direct, and confident. Their brain has quickly identified a suitable answer and delivered it. Another person pauses. From the outside, that pause can be misinterpreted. It might look like hesitation, uncertainty, or even lack of understanding. But internally, something else may be happening. The brain is not stuck. It is working. It is running through possibilities, checking whether the answer fits the context, considering alternative interpretations, and evaluating the implications of different responses. This process takes time because it involves more steps. Now place that same kind of processing into a busy environment. Every conversation, every tone of voice, every facial expression becomes input that can be processed at that deeper level. The brain is not just registering what is happening, it is analyzing it, connecting it, expanding it. This creates a richer understanding, but it also increases the load, because each piece of input is not just received, it is explored, and exploration requires resources. This is where silence becomes important again. In a noisy environment, the brain has to divide its capacity between external input and internal processing. If too much input arrives at once, there is less capacity available for deeper analysis. The system becomes forced to simplify, to respond more quickly, or to drop information. For someone whose natural tendency is toward deeper processing, this can feel limiting. It's not just that the environment is loud, it's that it interferes with how the brain prefers to operate. Silence removes that interference. Without constant incoming signals, the brain can devote more of its capacity to internal work. It can follow a line of thought further, examine it more carefully, and build more detailed connections. This is why some people think more clearly in quiet environments. It's not simply that noise is distracting. It's that noise competes with the internal processes that their thinking relies on. There is also an interesting side effect. When a brain is used to deeper processing, it may automatically begin analyzing even when it is not required. A simple interaction can trigger layers of interpretation. What was said, what was implied, what might happen next. In a calm environment, this is manageable. In a highly stimulating one, it can become overwhelming, not because anything is wrong, but because the system is doing more work per unit of input. This again shows that the need for silence is not just about avoiding sound. It is about creating the conditions where a particular style of processing can function properly. Without that condition, the system is constantly forced into a state where it cannot operate in its natural way. And over time, that creates strain. Silence, then, is not just rest, it is alignment. A state where the brain can process information at the depth it is built for without being overloaded by the volume of incoming signals. If you want to see how important silence can be for certain kinds of thinking, try a simple experiment. Take a problem that requires real concentration, not something automatic, but something that needs you to hold multiple ideas in your mind at once. It could be understanding a complex concept, planning something in detail, or trying to connect different pieces of information into a single clear picture. Now try to do it in a noisy environment. Voices are overlapping. Someone nearby is talking, music is playing. Small distractions keep pulling your attention away. Even if you try to focus, part of your brain is still tracking those sounds. It is deciding whether they matter, whether you need to respond, whether something important is happening. Then try the same task in silence. The difference is not subtle. In silence, your thoughts feel more continuous. You can follow a line of reasoning without interruption. You don't have to constantly restart or reassemble your thinking. The mental space feels more stable, more controlled. This difference reveals something important about how the brain works. The brain does not have unlimited capacity. It cannot fully process everything at once. There is a limit to how much information can be handled simultaneously, especially when that information requires attention and interpretation. You can think of this as bandwidth. External input uses some of that bandwidth. Internal thinking uses it as well. When the environment is noisy and complex, a large portion of that capacity is consumed just by managing incoming signals. What remains for internal processing is reduced. For simple tasks, this reduction may not matter. But for complex thinking, where ideas must be held, compared and developed, it becomes critical. If the available capacity drops below a certain level, the quality of thinking changes. Thoughts become fragmented. Connections are harder to maintain. You may feel like you are thinking, but the depth is reduced. This is why silence can dramatically improve clarity. It does not make the brain more powerful. It simply frees up resources. When external input decreases, more capacity becomes available for internal processes. The brain can sustain attention longer, explore ideas more deeply, and maintain coherence across multiple steps of reasoning. For someone whose thinking relies heavily on this kind of internal continuity, silence is not just helpful, it is required. Without it, their thinking is constantly interrupted at a level that may not even be consciously noticeable. The brain is forced to divide itself between processing the environment and processing its own thoughts. And that division reduces efficiency. There is also another subtle effect. In a quiet environment, the brain's internal signals become more distinct. Thoughts are easier to detect, follow, and refine. In a noisy environment, those internal signals compete with external ones, making them harder to sustain. It's not that the thoughts disappear. They become harder to hold. This creates the experience that thinking itself is more difficult, when in reality the underlying capacity is still there. It is just being shared with other demands. This is why some people instinctively seek silence when they need to think clearly. Not because they dislike noise in a general sense, but because their cognitive system depends on a certain level of stability to function at its best. Silence provides that stability. It creates a condition where the brain is no longer divided, where attention can remain focused, and where complex ideas can develop without interruption. And for certain minds, that condition is not optional. It is essential for clear thinking itself. If you look closely at all of this, something deeper begins to emerge. The need for silence is not just about sound or even about thinking clearly. It points to a more fundamental idea. The same external world does not produce the same internal experience for everyone. Two people can sit in the same room, hearing the same voices, seeing the same movements, surrounded by the same environment, and yet their experiences can be completely different. One feels engaged, energized, and mentally sharp. The other feels pressure building, attention splitting, and clarity slowly fading. Nothing in the environment has changed. The difference is entirely in how the brain is processing what is there. This challenges a very common assumption. We tend to think of reality as something fixed and shared. If two people are in the same place, we assume they are experiencing essentially the same thing. Differences are often explained in terms of mood or personality, but what neuroscience suggests is more subtle. The brain is not just receiving reality. It is actively shaping it. Every sound you hear is not just a physical vibration reaching your ear. It is a signal that your brain interprets, filters, amplifies, or suppresses. The same sound can feel loud or quiet, distracting or ignorable, depending on how your brain processes it. In this sense, noise is not just out there. It is something that exists partly in the interaction between the world and your nervous system. For someone whose brain responds strongly to incoming signals, the world can feel more intense, more detailed, but also more demanding. Each element carries weight, requiring attention and processing. For someone whose brain filters more aggressively, the same world can feel simpler, more manageable. Less detail is processed, which reduces load and allows for quicker responses. Neither experience is more real than the other. They are both valid interpretations of the same underlying input. This idea becomes especially clear when you consider silence. Silence is not an absolute state. Even in a quiet room, there are still sounds, distant noise, subtle movements, the hum of the environment. But for some brains, these signals are minimized, filtered to the point where they no longer demand attention. For others, those same subtle signals may remain noticeable. So silence itself is partly constructed. It is not just the absence of sound, but the absence of signals that the brain chooses to process. This means that when someone seeks silence, they are not simply moving to a quieter place. They are seeking a state where their brain reduces input to a level that feels manageable, a state where the balance between external demand and internal capacity is restored. And this leads to an important realization. Experience is not determined solely by the external world. It is co-created by the brain. The environment provides signals, but the brain decides how those signals are interpreted, how much attention they receive, and how strongly they affect the system. This is why two people can disagree, not just about opinions, but about what something feels like. Because what it feels like is not just in the world. It is in the processing. Silence then becomes more than just a condition. It becomes a window into how reality itself is constructed. It shows that what we experience is not a direct copy of the world, but a model built by the brain, one that varies from person to person, depending on how their system is tuned. And once you see that, it becomes harder to think of experience as something fixed or universal. It begins to look more like something personal, something shaped continuously by the way your brain interacts with the world around you. Once we accept that experience is shaped by the brain, the next layer to explore is how thinking itself interacts with this personal reality. The way the brain processes information is not just a passive reception of signals from the world. It is an active construction, a constant building of a model of reality from raw input. When noise or stimulation is high, this construction becomes more fragmented. The brain has to allocate resources not only to understanding the external environment, but also to maintaining coherence internally. For someone whose cognitive style relies heavily on internal processing, high stimulation imposes a subtle but persistent strain. It is not always noticeable to others outwardly. The person may appear calm or even engaged, but internally, their brain is constantly tracking multiple threads, analyzing input, predicting outcomes, and evaluating possibilities. Each of these operations uses finite cognitive bandwidth. As the volume of incoming information increases, less capacity remains for deeper thought. This is why a noisy or highly stimulating environment can feel overwhelming without necessarily causing overt stress. It is a quiet but persistent cognitive pressure. Silence allows the brain to redistribute its capacity. With fewer external demands, more of the neural system can focus inward. Thoughts can be followed to completion, patterns can be recognized more effectively, and connections between ideas can form without interruption. The mind can simulate scenarios, reflect on past experiences, and explore creative possibilities. In this sense, silence is not passive. It is a condition for active, high-level mental processing. Interestingly, the benefits of silence are not limited to just quiet environments. The effect occurs whenever the brain can reduce unnecessary input, whether that is through focusing attention, closing one's eyes, or mentally tuning out distractions. The critical factor is not the absence of sound alone, but the reduction of competing signals that require processing. The brain uses this reprieve to consolidate information, organize thoughts, and restore internal equilibrium. This also explains why the experience of silence can differ between individuals. What one person perceives as peaceful quiet might feel oppressive to someone whose brain is less sensitive to stimulation or who thrives on a higher level of external input. Conversely, what seems like moderate background noise to one person may feel overwhelming to another. This variability demonstrates that reality, as experienced, is always relative. It is filtered through the brain's processing architecture, which differs from person to person. The need for silence, then, is not a simple preference or a matter of temperament. It is a functional requirement for certain cognitive styles. For brains that operate at higher levels of internal processing or heightened sensitivity to input, silence is a necessary condition for optimal functioning. Without it, mental energy is continuously diverted to managing external signals, leaving less available for reasoning, reflection, and insight. Recognizing this leads to a profound shift in perspective. We often measure engagement, intelligence, or productivity by outward activity, conversation, movement, or visible response. Yet much of what the brain is doing happens internally, invisible to others. Someone sitting quietly, appearing passive, may be processing more information and making more complex internal computations than someone actively engaged in external interactions. This understanding challenges how we interpret behavior and experience. Silence is not absence, it is presence in a different form. It is a state where the brain operates in its preferred mode, building, reflecting, and interpreting reality internally. By seeing silence this way, we start to appreciate that much of what is essential in cognition, perception, and understanding occurs beneath the surface in a private, richly active space that is as real and important as any observable action. When we examine the brain in this way, it becomes clear that the experience of silence is not merely a matter of comfort or preference. It is fundamentally tied to how cognitive processes unfold, how attention is allocated, and how mental energy is distributed. The brain has finite resources, and processing external stimuli consumes a significant portion of those resources. Sounds, movements, and social cues all demand attention, even when you are not consciously focusing on them. The more sensitive or deeply processing the brain is, the greater the consumption of these cognitive resources. Imagine a scenario where someone is attempting to solve a complex problem while being exposed to multiple simultaneous conversations. The auditory input competes with internal thought, requiring the brain to divide its attention. Each external signal reduces the capacity available for deep internal processing, slowing reasoning and reducing clarity. This effect is not uniform. It varies depending on the individual's baseline sensitivity, processing depth, and internal cognitive style. Some people are able to maintain focus despite a high level of external stimulation, while others experience a gradual erosion of clarity, concentration, and cognitive energy. Silence mitigates this effect. By reducing the number of external demands, the brain can reallocate resources to internal processes. Attention can be sustained longer, complex reasoning can proceed without interruption, and connections between ideas can be explored fully. For individuals whose cognitive style involves deep, extended processing, this is not optional, it is essential. Without sufficient quiet, the brain's natural processing patterns are disrupted, limiting understanding and clarity. This also explains why some people instinctively seek solitude or quiet environments when engaging in difficult mental tasks. Their brains require conditions that minimize unnecessary input to function optimally. Silence creates an environment in which internal computation, reflection, and reasoning can proceed without competing interference. The experience is not merely about avoiding external noise, it is about maximizing internal efficiency and clarity. Interestingly, this relationship between external input and internal processing suggests a broader principle about how brains construct experience. Two people in the same environment can experience it very differently. One person may feel energized and alert, absorbing information effortlessly. Another may feel mentally strained, fatigued, or distracted. The objective environment is identical, yet the subjective experience differs dramatically. This variability highlights that perception is not a passive reception of reality. It is an active construction shaped by the brain's sensitivity, processing style, and resource allocation. Moreover, the need for silence underscores the importance of understanding cognitive diversity. What seems like a lack of engagement from the outside may represent a highly active internal state. A quiet person may be processing more information, analyzing more deeply, and simulating more possibilities than someone outwardly active. Silence is not absence. It is a mode of engagement that occurs within the internal landscape of the mind. Recognizing this also shifts how we evaluate productivity, learning, and attention. Traditional metrics often emphasize visible activity, speech, movement, or overt participation, while neglecting internal cognitive work. Yet for certain types of processing, the most important activity is invisible. Silence provides the necessary conditions for this internal work to occur efficiently and effectively. Ultimately, the value of silence is not simply comfort, preference, or avoidance. It is a functional necessity for cognitive equilibrium, a condition that allows the brain to process information at its preferred depth. Understanding this allows us to appreciate that reality, as experienced, is shaped not only by the external environment, but also by the architecture and operational patterns of the brain. Silence is the medium in which some of the mind's most complex and essential work is performed, revealing that much of what is real and meaningful occurs internally, in a space that is profoundly active even when it appears outwardly still. Once we recognize the brain as an active constructor of experience, we start to see why silence holds such profound importance for some people. The brain is constantly balancing multiple streams of information, incoming sensory data, ongoing thoughts, and internal predictions about what will happen next. Each stream competes for limited cognitive resources. When external signals are strong, the brain dedicates much of its capacity to managing them. When those signals are reduced, more resources become available for internal processing. This is why silence can feel so restorative. It is not a passive void, but an active state in which the brain can operate more efficiently. For someone with heightened sensitivity or a tendency for deep processing, this efficiency is critical. In noisy environments, attention is fragmented. Thoughts may remain incomplete, and connections between ideas can be harder to form. In silence, these same processes can unfold naturally. The mind can explore complex concepts, integrate new information with past knowledge, and simulate possible outcomes without being interrupted by external noise. The effect of silence is particularly evident in how people solve problems and process information. In a quiet environment, the brain can maintain longer chains of thought, allowing for more complex reasoning. Ideas that might be overlooked or dismissed in a noisy setting can be fully examined. Patterns become easier to detect, subtle relationships more apparent, and creative solutions more accessible. It is not that the brain suddenly gains additional capacity, but that its existing capacity is freed from the demands of external input and can be applied to internal computation. Silence also reveals the deeply personal nature of experience. Two people in identical situations can experience the same external stimuli in entirely different ways. One may be energized, alert, and engaged, while the other feels mentally fatigued or overloaded. The objective world has not changed, yet the subjective experience diverges. This highlights a fundamental principle: perception is not a mirror of reality, it is a model constructed by the brain. Each brain interprets signals according to its own baseline sensitivity, processing style, and internal priorities. Furthermore, the need for silence challenges conventional ideas about productivity and engagement. Society often equates visible activity with effectiveness, assuming that people who speak, act, or interact are thinking more deeply. Yet for some minds, the most profound mental activity occurs quietly, internally. A person sitting still, seemingly inactive, may be processing complex information, generating insights, or evaluating scenarios far more deeply than someone visibly engaged. Silence, therefore, becomes a functional tool, enabling the brain to operate in its preferred mode and achieve cognitive depth that would be difficult or impossible in a stimulating environment. Silence is not uniform in its effect. The degree to which a person benefits depends on their brain's architecture and processing style. Some brains thrive on external input and minimal quiet, while others require extended periods of low stimulation to function optimally. This diversity underscores the importance of understanding cognitive differences rather than judging behaviors superficially. Ultimately, silence is not merely the absence of sound. It is a state that allows the brain to restore equilibrium, allocate resources efficiently, and engage in the complex, high-level processing that defines human thought. Recognizing the necessity of silence reveals that much of what matters in cognition and perception is internal, hidden from view, and deeply personal. It demonstrates that our experience of reality is shaped as much by the structure and functioning of our brains as by the external world itself. Understanding this reshapes how we think about attention, thought, and even what it means to engage with the world.